Welcome to The Explainer. Today we're diving straight into one of the absolute biggest headaches in modern enterprise connectivity. If your organization relies on cloud applications, remote workers, or connected devices, and let's be real, that's pretty much all of us at this point, you've definitely felt the growing pains of an outdated network. We've all been that one frozen loading screen away from just tossing our laptops right out the window. So today, we're going to unjam that network by demystifying SD-WAN. Think about your own day-to-day for a second. Imagine you're on a super crucial video call, and right as you're making your brilliant point, your screen freezes, usually on a highly unflattering facial expression, right? We've all been there. Or maybe you've dealt with that incredibly sluggish remote access just trying to open a basic spreadsheet. It's annoying for us personally, but on an enterprise level, it is a massive operational roadblock. So why exactly are these traditional networks, the ones we've relied on for decades, suddenly buckling under the pressure?
Well, to really get the problem, imagine trying to navigate a massive traffic jam, but all you have is a paper map. You know your destination, you know where the physical roads are, but you have zero real-time data. You can't see the accidents ahead, you don't know about road closures, and you literally can't reroute. You're just stuck. Traditional network routing operates exactly like that static map. It just sends data down these fixed, predetermined paths, totally blind to how congested those paths might be getting.
So here is our roadmap for today's explainer. First, the network traffic jam. Second, enter SD-WAN. Third, SD-WAN versus traditional MPLS. Fourth, performance, cost, and security. And finally, the future of networking.
Okay, let's jump right into Section 1, the network traffic jam.
For the last couple of decades, the gold standard for wide area networks has been MPLS. Now, you can think of MPLS like a highly secure but ridiculously expensive private toll road. It was built for an era when all your corporate applications lived in one central physical data center. So if you're sitting in a branch office in Chicago, your data has to travel down this expensive toll road all the way back to the data center in New York before it can actually go anywhere else. But today, our apps live in the cloud, AWS, Azure, Office 365. Forcing all of that cloud-bound traffic through one centralized bottleneck is just inefficient, it's slow, and honestly, it is incredibly costly to scale up.
Which brings us to Section 2. Enter SD-WAN.
Let's break down exactly what this is. SD-WAN stands for Software-Defined Wide Area Network. The absolute key phrase you need to remember here is that it decouples networking hardware from its control mechanism. See, in the old days, the physical router box also held the brains that decided where traffic should go. SD-WAN takes those brains, the control plane, and separates them from the physical links, creating a virtual overlay. Because this management is now entirely software-based, you can control a massive global network from a single dashboard, pushing updates to every single branch instantly.
Going back to our earlier analogy, if traditional networking is that static paper map, SD-WAN is your network's dynamic GPS. It's basically Waze or Google Maps for your data. It is constantly evaluating all the available roads, whether that's a broadband connection, an LTE cellular signal, or even your existing MPLS line, and it does this in real time. If it senses packet loss or traffic jam on one route, it automatically shifts your critical video call over to a faster path. It literally fixes the problem before you even notice a blip.
To kind of ground this concept, let's look at the three main pieces making this happen. First, you have the SD-WAN edge. Think of these as the physical doorways, the appliances sitting right at your remote branch offices. Second is the SD-WAN controller, which is the brain essentially managing policies and picking the best paths. And third is the SD-WAN gateway. This acts as the direct on-ramp, seamlessly connecting those remote edges straight into the cloud. Together, they form this incredibly cohesive, smart architecture. Moving on to Section 3, SD-WAN versus traditional MPLS. When you put them side by side, the contrast is practically night and day. Traditional MPLS relies heavily on hardware and static manual routing. Say you want to open a new branch office. With MPLS, it can literally take months just to provision a new circuit. It's rigid and it's expensive. SD-WAN, being software-defined and dynamic, completely changes the game. You can spin up a new branch in days, sometimes hours, just by plugging in a standard broadband connection and letting the software configure the rest. The agility it gives an enterprise is just off the charts.
Let's look at Section 4, performance, cost, and security.
SD-WAN basically tackles three massive IT headaches all at once. For performance, it uses application-aware routing, meaning it knows to prioritize your live CEO broadcast over, say, a background software update.
For cost, it swaps out those crazy expensive MPLS lines for affordable public broadband without losing quality. And for security, it natively integrates modern frameworks like SASE and Zero Trust. That means it's constantly verifying who you are and what you have access to, keeping your data totally secure even over the public internet.
And to really put that cost-benefit into perspective, listen to this staggering number from Gartner. They found that enterprises moving away from traditional router-based WANs can see up to a 90% operational savings. 90%! That is an unbelievable return on investment, all from just ditching legacy circuits and letting smart software optimize affordable broadband.
Now, because you are sending corporate data over public broadband, you're probably thinking, security has got to be bulletproof, right? Absolutely. SD-WAN brings a heavy-duty security stack right to the network's edge. We're talking next-generation firewalls built directly into the software. It uses microsegmentation, which is basically like the watertight compartments on a submarine. If one section floods, the rest of the ship stays perfectly safe. Plus, with zero-trust network access, every single user and device is verified before they get anywhere near your data. To make sure the data actually traveling over the public internet is completely private, SD-WAN sets up these highly secure encrypted tunnels. Without getting too bogged down in the acronyms here, you can think of it as a three-step security detail. One guard checks the ID and agrees on a secret code, the second guard seals the package so nobody can tamper with it in transit, and the third completely scrambles the message inside. That three-step process is exactly how public broadband becomes just as secure as a private, dedicated line.
All right, Section 5. The future of networking.
The main takeaway here is that this isn't just some passing IT trend. It is a fundamental shift in how we build networks. Look at the market data. Back in 2021, the SD-WAN market was worth around $3.4 billion. By 2026, it's projected to absolutely skyrocket to $13.7 billion. Understanding this tech today is absolutely crucial because it's rapidly becoming the default standard for any modern enterprise.
Looking at 2026 and beyond, we're seeing some amazing trends supercharging SD-WAN. Artificial intelligence is stepping in to do predictive routing. It actually acts like a self-healing superpower, anticipating a traffic jam and rerouting your data before you ever experience a lag. We're also seeing deep integration with ultra-fast 5G and edge computing. Plus, SD-WAN is perfectly positioned to manage the thousands of IoT devices flooding our hospitals, factories, and offices. And because it optimizes bandwidth and relies less on massive hardware, it's really paving the way for greener networking. To wrap up our deep dive today, I want to leave you with this thought. In 2026, SD-WAN is not just a technology, it's a strategic tool that empowers businesses to stay agile. It really is the foundational layer that makes digital transformation, cloud adoption, and remote work actually function the way they were always supposed to.
Which leaves us with one final, pretty vital question to ask about your own organization's infrastructure. Is your network still relying on a paper map in a cloud-first world? If your teams are constantly battling bottlenecks, high costs, and a rigid architecture, it might just be time to upgrade to a smarter, software-defined GPS. Thanks so much for joining me on this explainer. Keep asking the right questions, and I'll catch you in the next one.